neutrons. For electrons, their charge is negative, protons, their charge is positive, and neutrons, their charge is neutral, which means zero. And
Why do
an
solids
atom,
have high? Why do solids have high melting points?
um, because the atomic particles in solids are tightly packed together.
The interaction between them.
Also,
Good.
things.
So let's move forward. Just a minute. So let's study. Without wasting the time, let's study the subatomic part, the first chapter, that is matter around the spheres. Sorry, matters in our surrounding.
Yes.
Matters in our surrounding. So, so Chakrika, that you have already been studied that what is matter actually. Okay? So anything that occupies space and has mass. Please keep your camera turned on. Okay. So for that the matter is turned. Okay. And
Then
eye
don't
contact between the teacher and the students. Isn't it?
you have a
So,
minute and turn the camera on.
okay. Because of some issue, I have forgotten to plug in my mic. Is my voice is clearly audible now?
Yes, sir.
Okay, so what I'm saying that what is matter? So matter is anything that occupies space and has mass is called matter. Okay, anything that occupies space and has mass is called matter, that you have already been answered this one. Simply, if I'm moving further, that we are just going to study in this chapter, what we're going to study, we are just going to study the three states of matter actually. Like for example, the matter that we see around us, we can classify them on the basis of their states. Same matter can be classified on the basis of whether they are pure substance or impure substance. Pure
Yes.
does not mean like if you have some impurities in it, it is pure or impure. No. Pure substance is one which is having one kinds of particles that we're going to study in the next class. Like in a class, same students can be classified on the basis of their genders, and they can be classified on the basis of their percentage of marks they score. They can be classified on the names or the alphabets, the first alphabet of their names. So similarly, the same matter can be classified on the basis of the physical states of matter. Okay, means the three states of matter, that how the physical state exists. One is solid, liquid, and gas. Okay, are you getting my point?
Yes.
Now you
Yes,
know
sir.
that solids. You have given me these examples already. Liquid and gas. These are the three states of matter. Along with these three states of matter, there are fourth and fifth states of matter also. One is plasma, and the one is Bose-Einstein condensate. Plasma is one which is found generally in stars. Okay, so and Bose-Einstein condensate is also a super states that generally does not exist naturally. This is an artificial state that is some different state that we're going to study in the higher classes. Okay,
Yes.
got it? So in this chapter, what we are going to study, that what are the characteristics of particles of matter, that how particles are arranged in matter, do they have a space between them, do if they have a space, then how can we prove this one? Okay, particles of matters are continuously moving or not moving. They have force of attractions. If they have force of attraction, so which kinds of state has more force of attraction between their particles, like solids do have or gases have. Okay, or we shall be going to study that what are the effects when we are changing the states of matter, then how we can, that how pressure will help us, whether on increasing the pressure, will the solid can easily get converted into liquid, or liquid get easily converted into gas, or increasing or decreasing the temperature. So we will going to study the effects of temperature and pressures, that how the temperature and pressures help us in changing the states of matter, and why does the temperature remain constant when the state is being changed. Like for example, ice melt at 0 degrees Celsius and freezes at 0 degrees Celsius. Why does the temperature remain constant at these states when the substance is changing its states? We're going to study that why do we feel uncomfort on a humid day, that on a humid day when there is a lot of humidity, then our sweat does not get easily evaporated and we feel uncomfort. Why does evaporation causes cooling effect? Okay, we shall be going to study different types of graphs, uh, okay, and other things also in this chapter. So without wasting the times, let's study this chapter. So please
Yes.
note down with the definition. I know that it is an easy definition, but since it is a chapter, you must have the proper notes. Start
Yes.
writing. First, write down the name of the chapter, matters in our surrounding. Just a minute. There is someone at the door. Let me come. Okay, just note it down. Yes, you noted.
Yes, sir.
Okay. What do you mean by the word characteristics?
The way they're made of, like what their features are.
Yeah, characteristics means features. That if I'm saying that matter is made up of particles, and particles must have some characteristics, na?
Yes, sir.
Okay, like what could be the characteristics of a mobile phone? That it must have a speaker, a display, a camera. Okay, has the facility of calling and getting received. Okay, so that is the features of a mobile phone. That is the characteristics of a mobile phone. So easily you can recognize that it is a mobile phone. And if I give you one mobile phone, another one is a simple a table lamp. So you can easily distinguish between table lamp and a mobile phone. You will not say that this is a, you will not call a refrigerator as a TV, because you know
Yes.
that TV and refrigerator are different things. So similarly, characteristics means that what are the features. So what
Yes.
particles of matters have a space between them. This is simple characteristics of particles of matters, that they have a space. Like for example, when you have some uh, water, okay, and you take some water and you mark their level. You mark level, particular level with a light pen. Okay, means which is not having much, means thin pen which is having thin width. Okay, means okay. So when you mark that level, you add some after labeling that one, you add some 3 to 4 tablespoon of sugar to it.
Yes, sir.
And initially, when the sugar is not dissolved, you will find that the slightly the level is being raised. The level rises up
Yes.
because it is not dissolved. Okay, this is in the bottom, so the level of the water will rises up because in that place the crystals of sugar has taken that place. Means water has been removed and the crystal of water has taken that place.
Yes.
Because of that, the water level rises. But when you start stirring the solution, then during that time, the crystal, which is made up of millions of tiny particles of sugar, when the sugar and the water particles or sugar crystals and the particles of sugar and the water layers are being rubbing each other one by one, the particles of that crystal of sugar will break and they will goes into the space between the water particles. Okay, don't think that
Yes.
that crystal that you are having, that is a one particle. No, it is having time. It is a crystal which is carrying billions of particles of sugar.
Yes.
Okay, so these particles will goes into the space. These are very tiny particles of sugar and will occupy the space. And after some time, when the whole sugar get dissolved, you will notice that the level of the water rise, which was rising, it again reaches to its original position that it was having earlier. Okay, but what would happen here is that, is there any change from
No,
the
sir.
previous water and this one? Yes, there is a change. That is density change. The density is mass per unit volume. For the fixed volume of water, now the mass of that water solution has been increased. Okay, you added
Yes.
what sugar to it. The sugar goes into the space of water. Its volume will remain same, but the mass of the solution will rises up because now it is also carrying the particles of sugar in between them. So this is the density of the water will increases up. Okay. So this is the characteristics of particles of matter. So please draw these diagrams and then we shall be moving further. Do the solids
Yeah.
have space between them? Particles of solids?
Not really, sir. They're tightly packed.
They are tightly packed, but they do have. When like this is the first layers of solid particle, this is another layer of solid particle. So you see that the space, blue color space. So this is a space between them. Okay. When you have balls placed over the balls, this you will study in the 11th standard, the states of matter, the solid states. There you will find that these are called voids, voids, voids. Voids are
Yes.
the space between the particles of solids. Okay.
Yes.
So please note it down. You done?
Just a second. Yes, sir.
Okay, so please note it down the statement, note this statement. When we dissolve salt in water, the particles of water get into the space between the particles of water. And when water get dissolved, no increase in volume of water will take place.
Yes, sir.
Now, what is the next one is that particles of matters are continuously moving. Can you have any examples regarding to this one, that how can you prove that particles of matters are continuously moving?
I didn't get it, sir. I didn't get it, sir.
You didn't get that. We can say that particles of matters are continuously moving. How can we prove this one? How can we prove that particles of matters are continuously moving? So this is a very simple answer for this one, that we know that particles of matters are continuously moving. How can we prove this one? There are several examples we can prove this one. Like for example, if you have a beaker which is carrying some water, and you add some potassium permanganate which is purple in color, a crystal of potassium permanganate which is purple in color. When it goes into the water, initially it will purple that water in which, that corner of water in which the crystal is being dropped. Not on the whole beaker. You have one crystal, you just pour it. It will, but after some time you will see that the particles, the whole solution will become purple. And you
Yes.
know that motion is, in physics, is represented by the kinetic energy. And we have
Yes.
been studying that more the hotter a substance, yeah, or we can simply say that hotter the substance, more will it is going to have the kinetic energy, more it is going to have the kinetic energy. Okay. So we
Yes.
have experimentally observed this one, that we take a cold water and hot water, we add potassium permanganate crystal to both of them. We find that the purple, the water will become purple more at faster rate in that, which in that beaker which is hotter, which is carrying hot water. Okay. And
Yes.
the color will, and the diffusion rate will be slower in the cold water, so indicating that the particles of matters are continuously moving. So let me show you this one with the help of a video so that you can understand it much better. Is it visible?
You can still see the yes, sir.
You can check it here, that it is a crystal of potassium permanganate. When we add it to it, it is, one is cold water, another one is hot water. This is cold. This one is hot water. So you will find that diffusion is means it is faster in hot water as comparison to that of cold water. Okay.
Yes.
Same question comes in examination for this one, that why do the smell of cooking food, hot cooking food, reaches everywhere in the house, but the food that is kept out from the refrigerator? Okay, if your mother cooks some food
Mm.
last night for the dinner, okay, and during when she was cooking that food, the smell of that food reaches everywhere because it is hot.
Yes.
But when some of the food is not, that is being not or that is not being eaten or not being consumed, okay, so that remaining food your mother cooked, kept in the refrigerator, so that we can have that one in the breakfast also.
Mm.
So next day, when she kept that food out uh, on the table from the refrigerator, it's cold. The smell of that cold food is not reaching everywhere. So the reason, what is the reason? What is the reason behind it? What could be the reason? Why the smell of the cooking food, when it is the food being cooked, its smell is reaching everywhere. But when we are just simply we just kept the food which is cold, which is not having means it is cold simply. So why the smell of that food is not reaching to the larger distance at faster rate? The reason behind it
Yes.
is very simple, that during when the food is being cooked, it has much kinetic energy. The particles are hot. They can travel at faster rate. Okay.
Yes.
Motion can be done because motion of the particle is done by the kinetic energy, and hot food have much kinetic energy. So it will travel at faster distance, and at a greater distance, means faster rate with large and more distance. Similarly, if the
Yeah.
food is kept cold in the ref, it is cold food, which is whose particles not going to have much kinetic energy, so they will not travel at faster distance. Okay, because of that, the smell will not reach us so larger distance. Okay, understood.
Yes.
So please
Yes.
draw these diagrams. And this that how can we say that particles of matter is continuously moving. So when we add crystal of potassium permanganate and the incense stick, burning incense stick, smell reaches everywhere in the house. When we perfume our clothes, then its smell reaches. It's just because of that particles are continuously moving.
Yes.
Draw this one.
I've drawn the first two. I have to draw the second two. Good.
So the question will come that with the help of an example, illustrate that the particles of matters are continuously moving. So particles of matters are continuously moving. It can be explained by several examples. The smell of the cooking food reaches everywhere in the house. Okay, because the particles of matters are continuously moving. Okay, note it down, please. Done? Your voice is not coming properly. Another question is
Yes.
that when we drop a potassium permanganate, when a drop of potassium permanganate is added to water, the whole water turn purple due to continuous motion between the particles of matter. Okay, so this is the reason. Please note this one also. Done?
Oops, I'm still noting it down.
Okay. So still writing. Now the question comes, this is very important, that why does the smell of cooking food reaches everywhere in the house, but the smell of the food kept in the refrigerator, cold food don't? So please note down the questions and then write the answer for this one.
Yes, sir. I'm done, sir.
You noted the answer also.
I have to continue.
Done? Okay.
Yes.
Now we shall be moving towards this one, that how can we say that the particles of matters are very, very small? We can say that how can we say that these are very, very tiny?
Oh,
And you
microscope.
do you have any idea? No. Okay, uh let me explain you that how, like for example, if you are just multiplying or not multiplying, just adding whatever the number. Like for example, you started from any number, like you said 1 plus 1 is 2, 2 plus 2 is 4, 4 plus
Yes.
4 is 8, 8
8.
plus 8 is 16, 16 plus 16 is 32, 32 plus 32 is, when you keep on dividing, and if you go means you will when you keep on means adding or doing like this, you will go we can simply say that even of 20 to 30 times, if you multiply there, you will go into the crores. It's a big number.
Yes.
Okay. Same thing when we are dividing the half, like you have 1 crore divided by half, you will get 50 lakhs. 50 lakh
Yes.
divided by half, you will get, or even of doing this one, you can see that, just let me explain you this one, that how this number can be. That before explaining the term, let me explain you that what actually I'm saying and I'm trying to say. You have to divide 1/10 of everything. Like for example, you take, or you have to multiply 10 times. Like for example, 2, the double of 10 times of 2 is 20.
Yes, sir.
Okay. And you have to
Yes, sir.
double this one also. Okay. 20, 20, then 200. Okay. 200, then 2000, then 2 lakhs. Sorry, 20,000. Okay. Then, then how much?
2
It
lakh.
is 2 lakhs. Okay. 2 lakhs and then 20 lakhs and then 2 crores. Okay. 2 lakhs
Yes.
and then 20 lakhs and then 2 crores. 1, 2, 3, 4, 5, 6, 7. Even you are doing this one for the 7 times, the 2 when get multiplied by 10 times, so you will get, for the 7 time you will get 2 crore, 2 crore,
Yes.
and you are multiplying by 10 7 times.
Yes, sir.
Similarly, if you are having 2 crores, and if you divided 2 crore divided by 1/10,
Mm.
so
Yes, sir.
you will get 2 crore 1/10 is how much
Two.
it is? Hmm? It will be 20 lakhs. 20 lakhs to divided by 10, you will get how much? You will get
Uh,
this one simply 2 lakhs, then 20, then 20,000, then 2,000, then 200, and 20. Okay, same. So similarly, like if I'm having this crystal of, you take some solution, you take 100 ml of water, pure 100 ml of water, and you add potassium permanganate to it, KMnO4. You take KMnO4, the potassium permanganate to it.
yes.
And now this will become very dark, purple.
Yes, sir.
Okay. Now when you add potassium permanganate is same that a purple color substance that
Yes.
we have seen in the video.
Yes.
Now you take the fresh 10 ml of water, 190 ml of water, 90 ml of water, and you add 10 ml of this water, and you add 10 ml of this solution to it. You will feel still
Yes.
it is how much time?
100.
It is means it is 1/10 time of this one. It is, you take this sample and you add to 90 ml, it is 1/10. Okay, got it?
Yes, sir.
Then you add this one to mix this one. Still this is having some we can say that it is having some purple color. Okay.
Mm.
Now you have this next 10 ml of water, you add it to this one, to next 90 ml of fresh water, and you take the sample from this one and now you add it to this one.
Yes, sir.
On repeating 5 to 6 times, you have seen that you have diluted, and you are always doing this one. So you have diluted this for the 7. Means if you repeat this experiment for the 7 times, you have diluted this solution to 1 crore times. 1 crore time the concentration of the seventh beaker will be less. 1 crore time. Are you getting my
Yes.
point? What I'm saying? That when you keep on dividing 2 crore for the 7 times, you will get 2. Same, if you divide 1 crore for the 7 times, you will get 1. So whatever the
Yes.
concentration of this solution first in the first beaker is, it will be the 1 croreth in the seventh. And still in the seventh beaker, you will see that still it is having very, very light purple color, indicating that the particles of matters are very, 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 very small. Even though
Yes.
in this one you will not be able to, you will able to see the particles, but when you are doing this one and you are having the seventh beaker, you will find that still very light purple color is there, indicating that even if the solution is diluted for the 1 crore times, you cannot dilute the solution for the 1 crore time normally, but this is the way that you can dilute for the
Yes.
1 crore times, then even the particles will be there, some of the particles will be there, regarding that the particles of metals are very, very small.
Yes.
Are you getting my point? So
Yes.
let me show you this experiment, just a minute.
Yes.
This is an experiment to show this one that the particles of metals are very, very small. You take a pinch of potassium permanganate and add it to fresh one. What? Because this camera is not a high definition camera. Okay. So in the fourth and fifth beaker, you will not be able to catch the color of this one. But in real life, if you did this one, even in the seventh beaker, you will find that the particles of something. And like for example, if you have a piece of paper,
Yes, sir.
if you fold it 8 times, you cannot fold up any paper or any big sheet. Like for example, even if it is a sheet of uh, uh, the sheet of your room, even you cannot fold it for the 8 times. It's dividing something for the 8 times is creating a very, very small thing, but you cannot fold it because of the paper probably. But what I'm saying is that when we are dividing something for the 1 crore times,
Yes.
even if you have a this pen, and this pen, if you, no, it is not visible. So even if you have a piece of paper, you do 1 crore time fractions, you will see that a very, very small particle will be there. 1 crore is a very big number.
Yes.
Okay, even in a stadium, when we see that more in a stadium, we see that more than 10 millions, 1 million, more than 10 lakhs people are there that are enjoying
Yes.
the cricket in the when the story when the whole auditorium is full. So you can see that the whole human beings, that is a very big in size. If you have only 10 lakhs of this one, 10 lakh of this one, the whole stadium will full up.
Yes.
So even then the population of 10 stadium will be 1 crore. Okay, so
Yes.
you can imagine this one, that when you are diluting something and you are still diluting that small particles for the 1 crore times, you will see that it is having a very strong color in this one. And then we take some 90 ml of 10 ml of water from it, and then adding it to next 100 ml. Now it is having some purple color. Then you take again from this one. Okay, so the third beaker, it is still showing some purple color. Okay,
Yes.
1, 2, 3, 4. When you take from this one, still it is showing purple color here. But it is, since the camera is not high definition camera, but you will observe this one, that it is not. You can see that it is colorless in the last one. No, it is not. But in the real life, you will see that there is some light pink color is also there. But even if you dilute it for the 6 to 7 times, it can dilute it. So indicating that the particles of matters are very, very small. They are very, very small. Okay, got it?
Yes. Yes.
So start writing this one, that the particles of matters are very, very small. So here the particles of matters are very, very small. Write down, illustrate an activity to show that particles of matters are very, very small.
Yes, sir, please go. Um,
Yes, you done this one?
sir, I'm in the last part. Oh, yes, sir.
Down the observation and the results. You done?
Yes, sir.
So that's all for Chakrika. Chakrika, that's we'll meet you in the next class. I hope you enjoy the class. You understood the concept that how do particles of matters have a space between them.